Hello class, Miss Arians here. I was just going to go over drawing those Lewis dot structures again with the calculations my formula way, which is I think is a little bit easier for some of you. It may help you a little bit. If you're understanding the other way, don't worry about it. I'm just trying to break it down a little bit more for you. So first off, we're going to start by naming or drawing the CCl4. And first we're going to arrange the elements with the least electronegative. Oh, let me get my pen here. A least electronegative is going to be our central atom. That's one way you can tell if it's a central atom. Okay, so in this case it's going to be carbon. So carbon is our central atom here. Now how do we tell how many bonds are forming and how many electrons are going to be the lone pairs? Well, I have a better equation for you. So first we're going to determine the number of bonds that the structure needs from this equation right here. This right here is going to be shared electrons. Then we have electrons needed. So I'm just going to abbreviate here, electrons needed. And then we have valence electrons. So to calculate electrons needed, you're going to multiply the number of atoms, okay, within whatever we're trying to draw by how many electrons that it needs to get its noble gas configuration. Everything, pretty much everything on the periodic table is going to want 8 valence electrons besides hydrogen. Hydrogen only wants 2. So hydrogen only wants 2. That's an exception to the octet rule. It only wants 2, but everything else normally wants 8 to be happy. 8 just makes it happy. So let's look at our example problem here. So, number of electrons needed. Okay, we have 5 atoms here, and how we figure that out is we just add them up. We have 4 chlorines plus this 1 carbon. That gives us 5 atoms. Each one of these wants to have 8 valence electrons. So the electrons needed is going to be 40. So the number of valence electrons, we can figure it out just like Miss Covarrubias did. And what we would do there is we have 1 carbon. Carbon is going to have 4 valence electrons. Plus, we are going to go 4 chlorines. And each one of those has 7 valence electrons. So we have 4 times 7, which is going to be 28, plus our other 4 gives us our 32. So 32 electrons is what is needed. Okay, or that's how many electrons, valence electrons we have, not electrons needed, sorry. So after that, what do we have to do? We have to plug both those numbers back into our formula. So the number of shared electrons is going to be 40 minus 32. 40 minus 32 is going to be 8. So we have 8 shared electrons. So if these electrons are being shared, that means that they are already bonded. So that's how many bonds we have. We know that it takes 2 electrons to form 1 bond. So we can just divide that by 2, and now we have 4 bonds that we can show. Okay, so here is our central atom. We have 1, 2, 3, 4 bonds. Now how do we determine the electrons that go on the outside? Okay, what we have to do is we are going to go ahead and look at the number of valence electrons. So if we have 32 valence electrons, and we know that 8 of those are shared electrons. If we subtract the 2, we end up with 24. Okay, we have 1, 2, 3, 4 things on the outside. Divide that each by 4, and we know that each one of those is going to get 6 lone pairs of electrons. So we can divide those up evenly. So then that gives us 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And that's how you would be able to draw that Lewis dot diagram. Another way to make sure that your diagram is correct is make sure that every single atom has 8 electrons. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8. That chlorine is happy. We're good there. So 1, 2, 3, 4, 5, 6, 7, 8. That chlorine is happy. 1, 2, 3, 4, 5, 6, 7, 8. That chlorine is happy. 1, 2, 3, 4, 5, 6, 7, 8. That chlorine is happy. And then obviously this carbon's happy because 1, 2, 3, 4, 5, 6, 7, 8 is sharing all of its electrons. So again, like I said, what we did there is we just placed the remaining 24 electrons around the atom to satisfy the octet rule. So you can just do the 32 minus 8 gives you 24, and you can just go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, okay? Or you can divide it up like I did. Okay, and to figure out how many we did that, it shows you right here. Valence electrons minus the 8 electrons in the bonds is going to give us our 24. That's how I got that. And that's how it should look, what you did. Okay, so I really hope this helped you. I'm going to do another quick, we could do a polyatomic ion, I guess. So we'll do nitrate. NO3, and that's going to have a -1 charge. So where's my, all right, hold on, let me get back to my slideshow. I don't know what's really going on here. Okay, so we're going to go ahead and do nitrate first. Nitrate. Okay, so let's look at this. We need to figure out this equation. So we have shared, oh nope, what's going on? Okay, pen, sorry, pen. Okay, shared electrons is equal to electrons needed minus valence electrons. Okay, so let's look at electrons needed first. We have 3 oxygen plus 1 nitrogen, so that's 4 atoms altogether. They all want 8 electrons, so we can go 8 times 4. It's going to give us 32 electrons. That is needed. Number of valence electrons, nitrogen, we have 1 nitrogen. It's going to want 5 valence electrons. And, oh yeah, it doesn't want it, it has it, I guess. And then we have 1 nitrogen on the bottom, cross those out. So we have plus, we have 3 oxygens, and each one of those has 6 valence electrons with 1 oxygen. Okay. So that's going to give us 23. So make sure that we include the charge here. So we have 1 extra electron, so we're going to plus 1 electron, which gives us 24 electrons that are valence electrons. So our electrons needed, 32 minus our 24, which is going to give us 8. So we know that we have 4 bonds. How do I know that? Because we have 8 divided by 2, because each bond is going to be, each bond needs 2 electrons. So if we have 8 electrons that are shared, remember I just plugged it in here, 8 electrons that are shared, we need 2 electrons for each bond, so we have 4 bonds altogether. So when we're drawing this, nitrogen is going to be the least electronegative, so that's going to go in the middle. And then we can have our double bond here. And then we would have our single bond here and a single bond here. So that would give us our 4 bonds. And then if we took our 8 minus our 24 minus 8 would give us however many electrons are left over. So we know that to make this happy, it's going to have 1, 2, 3, 4, 5, 6, 7, 8. Same with this one. And then this one has 1, 2, 3, 4, 5, 6, 7, 8. And obviously this is a polyatomic ion, so we gotta put brackets on it. Include the charge, which is going to be -1. So if I was to draw the resonance structures longhand, I would go ahead and do arrows. And I would put the double bond here then, since it's moving the double bond. We go here, and then include our electrons. It would look just like this. Make sure you put that in brackets. And then if I wanted to include the last one, this is going to be squeezed in here. Just like that. Oh, -1 charge. So that's how you would draw the resonance structures longhand, as well as do this for the polyatomic ion or the exception to the octet rule. I think that is it. Hopefully this video helps you a little bit more. If you have any questions, please feel free to ask, and I will do other example problems if you need more help. Have a great day.